Hello, and welcome to another video of explaining Lua and slowly becoming insane. Today we will get to know, or we will try building a basic collision, and we will do more in our for the beginning. We will talk about printing again for a second here, and I will show you how to use it because I last time apparently forgot how to do that, which is funny. Uh, Also, if you want to give a tab a name, you use these, and if you want to just comment, you use these. It doesn't really make a difference, but it's good to know, I would argue. So, um, obviously, the print function can only be called inside of the draw event because, well, if we are drawing nothing, then we can't print, right? So let's try printing something. What should we print? Well, a simple idea is to give the player HP, right? Because HP is helpful to have, otherwise you probably did. So we want to print player dot HP, right? Where do we want to print it? Well, we want to print it at player dot X and player dot Y minus, so it's up, like it's above the player, minus. Well, if we do 8, it will be drawn above, like in the tile above the player, which should be fine. So, colleagues, what happens now is instead of it being drawn around here, I mean, let's ignore that it's only one tile right now, it will be drawn here. But if we want it kind of, well, depends on the message. The message is not that long, it's just one number, so it will be 1. So we want to print it around here, which is, well, this is 8, is 10. So we do x plus 3. And this should print what we want to have. Let's run this and let's check. Well, yeah, that is exactly where we want it. Right now we still have gravity enabled, and we will build a very, very basic gravity system, which is more than just, you're falling down. And obviously we also want to be able to jump. That is probably obvious. So right now we have a very basic movement code. That one we will actually scratch because we are going to introduce a very basic way of introducing momentum, which is helpful just also for collision check and other things because you don't have to work with the x and y. What we are going to introduce is h speed, horizontal speed, which in this case is 0, and vertical speed, which is also 0. And these numbers are going to be the numbers we are actually manipulating. The player HS, well, it's going to be plus 8. Maybe. No, it's actually just going to be 8. Because as soon as we do plus 8, we are adding momentum. There's a lot of ways to do it. I will just do it with 8, setting it to 8. This allows me to just have a max speed immediately, and I don't have to deal with anything else. And this obviously is also speed, but it will be minus 8. So what we are going to do now is in every time we press a button, or not every time we press a button, every time we update the player, which will be updated in the player movement, we will say player.x, is equal. And we will add the player.hs on top of that. And this is simple. We will do the same thing as player.y is equal to plus player.yes. Now, it's important to look at what you're doing here because, again, they're flipped. Since gravity is a minus number right now, gravity is a positive number, we might not want to mess with this. Now, to have a platformer, you obviously also want to know if you are grounded, right? So we are going to introduce a state called is grounded, and that is a bool. It will be false at the beginning. Doesn't really matter because we will be checking for stuff. Now let's draw a slightly better map. The map is simple to draw, you just draw the tiles you want. So we're just going to build a little thingy like this. Obviously there's no condition yet, but that doesn't matter. Oops, that was by accident. So you might have noticed that there's some flags. These flags can be used to figure out, like not to figure out, to give things certain examples, certain effects, depending on the flag that we check for. So what we can do is in our movement function, we obviously want to be able to do that only. Well, we can just leave that there. We can write it more effective, but just to not confuse anyone, I'm going to make it relatively simple. So the gravity is something we will only be updating while there is no, while we are not grounded. So how do we figure out we're grounded? Well, you just saw I set the flag 0 on this sprite. So now there comes a little complicated code. Basically, if, and now we want to get the sprite on the map, like the sprite number of the sprite that is drawn on the map at the collision point where we want to check. So that is going to be mget, map get the sprite of the map. Now remember, the map is different from the sprites. So if you check for sprites, you need to do it differently. But since we wrote everything in a way that we are updating in tiles and not pixels, this should be fine. So we want to check if mget player.x plus player.hx. You know, this gives us the coordinate. Well, we also need player.y plus player.ds, right? So this will check if there's any, like if we have horizontal speed, then it will check, okay, is there something? It will get the sprite to the pile we are going to move to if we continue moving at the pace we are having right now. This will be a really stuttering movement, but as I said, for now it's okay. We don't, whatever, let's just, I haven't thought about what kind of game I'm making here, okay? I'm just explaining stuff. Now this only gets us the map. Of course, we could say if mget is equal to the number of the sprite, which is 16, but that isn't really good. So we want to get the flag of the sprite we just got, fget. Fget is simply you put in a sprite, and it will give you the flag it has. If this is equal to 1, or it's flag 0, then we set these two to 0. Player.hs player.vs equal to 0. Now, if I did this correctly, which most of the time I don't, I can't move because right now we are in a wall. Well, tough luck. Let's spawn our player somewhere else. Let's spawn them at not 0, 0, but let's try to spawn them around here, which would be 5, 3. make sure that you remember that the coordinates of the player currently will need to be multiplied by 8 to get the position on the map. So now we can't move. Why can't we move? Well, probably because currently player HS and VS is set to 0. No, it isn't, it's set to 8. So player.x, which is this, well, we haven't initialized the VS, have we? No, it is 0. So we shouldn't be checking anything below our player. I am confused, just as you are. Probably because I'm bad at explaining stuff. Let's check it. Well, we probably need to check flag flag 1. Why? Okay, this isn't intentional. Well, now we move really fucking fast. And the reason we are not actually having any collision is because we are checking the wrong one, the wrong instances. It shouldn't be button press. And we always need to reset these numbers. But I will be coming back to that in a bit. So, why did it not work before? The reason for that is simple. fget, this is not flag 0, it is flag 1. The 0 flag, like, if you pass into fget, if you pass nothing in it, it will return 0. It won't return nil, it will just return 0. So it just returns 0. It's not what we wanted, but hey. So of course, every time we move, we also want to reset our speed. Now, as you can see, we are not exactly on the tile where we want to be, right? We are slightly, we are not moving. Basically, we are in the middle of tiles, not where we should be. Because we are around here. Let's actually see. The middle part would be here. Now we can figure out where we move. Well, the player is not exactly aligned, is it? We need to align this pixel with this pixel. As you can see, this works. But it doesn't work in this direction. The reason for that is simple. Player HS is 8 or -8 depending on the direction you're moving in. But the mget needs to be divided by 8. Don't ask me why, but that's what needs to be done. Because it is sprite coordinates, not actual pixel coordinates. So if we divide this by 8, don't ask me why the fuck they did it this way. It is very confusing indeed. I struggled with that a lot the first time. So, now we have aligned the pixels. Just kidding, we just fixed a bug I made. That is live coding for you there. Figuring out what is wrong. You of course need a decent understanding. So why was that? Well, mget gets the sprite coordinate, not the map coordinate, which I forgot and didn't remember. So mget is simple, it just returns something. Another way of doing collision, this is one way. It is relatively effective because you can give everything just one flag. But if you want to have, let's say, a list, let's make it complicated. Imagine you have objects you want to interact with, right? You have like, I don't know, different objects that have different effects, but you want to put them all in the same folder. How do you do that? Well, you first get a table, which is called objects. In that table, you will store all your objects, and then you will build a function where you will object needs to be initialized. No, every object, every sprite has a different action. So we define a function. That function is, I don't know, interact. And we would pass it an x and a y. The x or y is the position where the player would be going, basically. And then in here, we would loop over all of them. Do you remember how to do that? Well, I'm guessing you do. So for e in all, oops, not for in all objects. And now in here, every object, we can actually introduce a couple of things. What we also want to introduce is local OBG. And this is actually important because this will be mset, mget. Mset also exists. I will be explaining that at some other point though. It's basically just, actually let me explain it right now, it's not that complicated. Mset is setting a sprite on the map. Mset gets the sprite. Sprite being whatever you want, I don't know, let's say 111, and then it gets an x and a y. And it will set that coordinate. I believe mset is the same as is also times 8. I don't entirely remember. But basically, we want to create a local object, which is mget, and we just pass in x. Remember, we want to divide by 8. You know, that depends on how you call the function. Of course, you could do it in the function call. It's easier to do it that way, then you can just forget about it and the function does everything for you. So now we know which object we are calling. Now we want to figure out if it's in any of these. So we just say if I dot, I don't know. Of course you need a sprite, right? So if the sprite is equal to the object, which just returns a sprite if you remember, then it's helpful if I actually type an if. Then we do something. I don't know. You can actually do I dot effect, and if effect is essentially a function that works. I don't have anything set, but this is how you could use a different approach. That was a really long tangent to achieve absolutely fucking nothing, but let's make our code a little more complete. Let's get this and Control D. That is not what I wanted. Let's copy this and paste it twice. And of course, now we want to have VS and VS. And facing we don't care about because we are moving up and down and currently we don't have any sprites for it. So now there's again figuring out which button you need to press to get the achievement. Now this is down. Down is actually plus, so we not plus. Now we only need up. By the way, the buttons, if you don't always want to like figure out which one it is, the way buttons work is you have button press. We've seen already. Let's go back here so I can make a little space. You have button press. And in button press, you can pass 1, 2, 3, 4, 5, 6, I believe. The arrow keys are 4 and then you have X and C. Yes. So 5 and 6, 5 is equal to X. And 6, that's 9. 6 is equal to not a house. Where is it? Where is it? C. It doesn't look like a C, it's a C. Or C. Now 1, 2, 3, 4, 5 are essentially the arrow keys. 1 being the arrow to the left. 1 left or F apparently. 2 being right. 3 being up or down. I think 3 is up. So that's essentially how it works. Of course, button and button press are just different in the same way. If you have button, then every frame the button is held, it will do what is in the button event. The button press is not every frame. It resets at some point, I'm not entirely sure. But just know that it is much slower when updating. Now, of course, well, we can actually not move up currently. So let's find where the up keys. Because, well, actually, let's see. Far 4, no, 3, because then we can actually check if I was correct or if I wasn't. So can we move up? No. Can we move up? No. So I probably can use them. Let's say 4. Now, why doesn't this work? It probably doesn't work because as soon as I press up or down, it just is stupid because I am stupid. Because I want to make sure that I find the right button. Yes. So now we can check. Yes. This works. Double buttons. So now we can move. We have collision. There's obviously something here that you can't see. So we can't move out, but I can, for example, do this. I believe there's a wall that I just can't see. We are currently only drawing the first position of the map or the camera. Now let's update this. Well, to update this, let's say we want to draw the full map. 0, 0, where to start. Basically, how the map works is you have x, and you have y, and you have x2, and you have y2. So, keeping that in mind, the map of Pico-8 is, obviously, we want to start at 0, 0. It is 128 by 64. So if we now do this, then, well, can't draw the entire map. Maybe it is even different. Not sure. This should be how the map works. It is how the map works. Let me check if I am stupid. Oh, fuck off. Pico-8. I don't want to teach wrong things, do I? Ah. No, it is slightly different. It is this. I will explain everything it does now. I know it looks a little intimidating at first, but you have cell X inside Y. And then you have SX, basically screen coordinate X and screen coordinate Y. That is what position will be at the top corner, the top left corner of the screen. And then, of course, you want to have cell width and cell height, which is how many cells you want to be drawing. So if you want to draw the entire map, you want to draw, I have to think for a second. Let me think. Well, cell X, cell Y, that is 0. Because, well, that is the up. Yeah, that's the upper left ones. Screen will also be 0, and this will also be 0, because we obviously want to start there. Now we know that 128 times 64 is the entire map, not C64. That would be an impressive explosive. And then the layer. What is the layer? The layer is just the flag that is set. Layer 1 would be this flag, and layer 1, 2, 3 would be this flag, 4 this, on 5 this one. You get the point. This is helpful if you want to, I don't know, draw weapons on one layer and other things on different layers. So by default, you can just pass nothing, then it's nil, which is layer 1. So this now draws the entire map. So why does it not draw the entire map? Simple person who has asked a question that I can't hear. Because we have a camera. And that camera, well, can only see what is, like, it can only see what is drawn, but it can also only see something in like a 64 by 64 screen, if I remember correctly. So if we want to center the player on the map, we say camera. And now the X and Y are the top left corner of the map, of the camera. So if we just say, we want to draw the map with player X and player.y, well, you're going to get the following. You get the problem. To fix that, you just, well, simple. The map is, the camera is 64 times 64. So if we want to have the center of that, that is very simple math. For here, we want to go up, go down 32 units, whatever. And on the right, we want to go plus 32 as well, if I remember correctly. And that was wrong because it's minus. Okay, it's both minus. Good thing I was completely wrong. And now we have decently centered up. It's not perfectly centered because it's actually 64 because I was wrong. Remembering all of these numbers can be. But yeah, now we can move our player around. We have collision. And we have a really simple movement code together with some collision. Of course, the collision is tile-based, so there's nothing fancy here, it's just boring. That's basically how you do these things, how you introduce this, how you use print. We're still printing the HP on top of the player, we don't really need that. So we are just going to ignore, to delete this. Now, what is the next thing we can introduce? Well, we have a nice movement code, and we can actually clean it up to get very few lines and very few tokens. Cleaning up is always a little boring because you need to figure out what to do, what not to do, blah, blah, blah. Basically, well, you want to figure out which one you're using a lot and then just write something else for it. Because player dot something is always 3 tokens. So if you manage to, for example, put player.hs into a variable, you set that to 8. Well, that's nice. So what you can do is you can say local hs facing, we're just going to ignore now, and local. Actually need to do it outside of this. Like local hs, and that will just by default be 0. So then we can update these two. We can also have local vs, which is also 0. And that means we can remove these ones. So player blah 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 blah. We haven't changed them yet. So we can just change the actual value. And then in this step, we can just use VS and HS. But the problem with this is if we don't have a global way of accessing them, we can't make shit like, I don't know, something that has a shockwave effect. We would have to add it into here, which is kind of annoying. So what we are going to do is we're going to say player.vs is equal to vs, and player.hs is equal to hs. That way we can get that effect by still saving a lot of tokens. And then after we of course reset this, and we don't need to reset these again because yeah, I'm not sure how much tokens we just saved, I didn't count, but we should have saved a lot. Now player.facing is 2 times here as well, so you could declare it once here, but then you still need to call it once here, which probably amounts to the same amount of tokens. You always have to kind of think about that. Now we could say player.x, blah blah blah. What we can do in here, well, we don't need player.hs and player.vs. So we can just remove all of these, which also saves a lot of tokens. As you can see, we just saved 2 tokens by doing absolutely fucking nothing. And the code didn't change. The code is still the same. So that's how you can clean up code. So now we have a nice movement function in only 31 lines of code. This of course doesn't, you can't like fucking attack anything, but we know where the player is facing and we know where the player is going. We know that by using this function, we could also write this into a function, say collision handler, which is actually something we will be doing right now. We will say function. And the reason for that is, well, you want to make sure that you can easily introduce new stuff. Like for example, if you want to have objects, you want to introduce them easily and not just try to write it in the main movement function, otherwise you can fuck up your movement. So we say collision handler. And the collision handler gets the, what does it get? It gets VS and HS. VS and HS. HS, VS. And let's say it also gets an X on the, because that will just save tokens. You will see why in a second. Now, we can just copy this shit completely and remove it from here and just copy it in here. And then we can say, okay, this is X and this is Y. But the way I wrote it, it doesn't work that way, because we are not actually turning anything. And now we are not really changing any variable. So this doesn't work the way I thought it would be. So that's actually not a good idea to do it this way. Unless you call it after this, which is certainly something you can do. Kind of defeats the purpose because we're not actually saving anything. Of course, we can introduce it in here. That will work probably, but it is kind of superficial and stupid, because we could just do, we could copy this, paste it in here. Oops. Copy that, paste it in here. Make sure there's 0 when this happens, and then end. And then we just, of course, we still need to call this. Oops, wrong button. And now remember this, we can't put it in here, but we can put it after we have updated this. So in here we will call this function, which gets HS and VS obviously, and XY. XY being player.x and player.y in this case. You can use the function for different things. Now the way I wrote it now, you can't use it for other shit. If I left it the way I did, which I didn't really think that far ahead, it would have worked. basically just saying, okay, set blah blah blah. That way we can just code it in. We can of course make different functions for different things, but we want to be efficient. Now, we fucked up the code now, and the reason for that is we did it after we actually updated it. So we are moving, and then afterwards we are checking if we collide with something. Pretty sure Team I has observed that already. Now we have nice movement, and we have some clean code. Sure, this function does slightly more tokens, and it kind of does the same thing as we did before, but it's just to demonstrate that you can actually have global functions that do decent stuff. I will paste it back in here because this is much less efficient, but it is something you should do from the beginning. Think about it and see how we can introduce things. So now we already have a slight thingy, and yeah, we have done basic collision, but we haven't used tables for it. And yeah, thank you for watching, and have a nice day. I will now show how to save stuff. If you want to save it as something else, you just save it as something else. Right now it already exists, so we want to overwrite it. There's also something called explore. Here you can look for things. For example, you can actually find my game here. Game I made a while back. This one. Made by me. But we can also, and this is probably very interesting for those who are really new here, we can find Celeste. Celeste was originally made in here. There's also hundreds of Celeste clones. But in here you can also find your own games. This is nothing. And you can also run them using stuff. Then you can check how it gets. Of course, you can also run it just the way I showed earlier, but this is something. You can also favorize them. Say favorite. Then it will get a little hard and it will show up in favorites. For example, if I say, you can also do it with the games in Explore. In Explore, you will find everything that has been updated. Let's favoritize this and let's see. Oh, it's in here. And you can look at other things. You can also open the thread in the browser. I'm not going to do that right now, but yeah, you can also click on similar cards and find similar stuff. I love how it. Yeah. You get the point. So that is how you use this. And to end the program, you just type stop down. Thank you for watching and goodbye.